1, 2, 3. Cool. Okay, since the room is almost full packed already, I think we can go ahead and leave Kasper for his keynote. And he will be talking about rethinking observability as a platform product. And he frankly has a lot to cover, so I'll just hand him the mic.
Perfect. Thank you so much. Yeah, so it seems like I got like an additional 10 minutes, so let's see how I can fill that. So thank you so much for being here, and thank you to the organizers for inviting me. It's a pleasure to be the one to open this event. So just let's give the organizers a big round of applause for setting this up. Yeah, so my name is Kasper. I currently work as, if this is working, it does, as a Director of Product Marketing and Developer Operations at Zero. I'm a former KubeCon, Cloud NativeCon co-chair. My last tenure was in London last year, which is, if you haven't been to a KubeCon, it's an awesome event. Definitely encourage everyone to go there if possible. Also, last year wrote this book around OpenTelemetry for dummies. It's like an introduction book into the space of OpenTelemetry and observability. So there will be a QR code later if you're interested in getting a copy. Also, a CNCF ambassador, I've been doing this since 2018. So I've been doing similar things as this event, organized community events in Denmark, also KCD in Denmark. Now it's Cloud Native Denmark. So if you are around the area or want to like submit a talk to Cloud Native Denmark, feel free to do so. It's in November. Yeah, I think that's enough about me. Today I want to talk a little bit about Kubernetes initially, because we will come to the observability part a little bit later, because I think Kubernetes changed a lot of things over the last 10 years, 11 years now. It sort of gave us these raw primitives and incredible powers, and we have like things like pods and services and deployments and all of the things that you know from this ecosystem, right? But it sort of failed to give us a product experience, like for developers especially. And I was back in 2019 at KubeCon, Cloud Native Con in San Diego, and Brian Lyles gave this awesome keynote where he mentioned this thing that Kubernetes is a platform for building platforms. And he also sort of extended that Kubernetes is a vehicle that takes us to our destination. And in that keynote, he also pointed out that Kubernetes sort of, back then at least, sort of missed its Rails moment, because Rails, if you're familiar with Ruby on Rails, it sort of gives the developer a paved path, like opinionated defaults. It's just easy to get started. Whereas Kubernetes, on the other hand, is quite complex, especially from a developer perspective. It has these raw powers, but it's sort of missing that product experience. So let's have a look at sort of the developer's cognitive load over time. So I tried to plot this, and it's sort of inspired by a good friend of mine, Daniel Bryant. His original talk is linked here as well. But this is sort of the cognitive load seen from the developer perspective over the last 25, 26 years. So back in the early days where we had the monolithic applications, right, it was fairly easy. We sort of had some clear boundaries that development was doing development and infrastructure was running infrastructure. So from that perspective, the cognitive load was quite easy to deal with. Then we started to move into a more distributed area with service-oriented architectures, and now we had sort of a network boundary that as a developer you needed to sort of take care of and deal with and build your services around. And then there was this moment where everything sort of like reset. I'm not sure if anyone or if everyone in here remembers this, but back then Heroku came around with like git push Heroku master, and from a development perspective, that this was super easy. To just git push Heroku master, and then everything was in production, and everything was taken care of for you. And then this happened, right? Kubernetes, microservices. We started to build more and more and more, and the cognitive load of the developer just increased and exploded, because now they had to deal with Docker containers and Kubernetes manifests and pods and services, ingress rules and whatnot. I was back at this point, I was working at a bank, and we did the same thing. We just pushed Kubernetes YAML, Docker files, and everything onto the developer, because back then there was this quote around shifting left, shifting security left, shifting observability left. Everything was shifting things onto the developer, and the cognitive load of the developers were just exploding. And I think platform engineering kind of emerged as this sort of savior to developers in this space, because that is really where the sort of the development cognitive load sort of like flattened a little bit again, because now we had a platform team that came in and tried to absorb a lot of the complexity, but still we have the raw power of Kubernetes underneath. So if we simplify this, so initially developers were just interacting directly with Kubernetes, and it kind of wasn't a good experience, right? Because developers probably has other things to do than figuring out how to run a kube control command or kubectl or whatever you call it. So we put this thing in between that we call a platform, right? So this is really the thing that is put in to absorb all of this complexity and still have the raw powers of Kubernetes underneath. So that makes developers more happy. And if we put this in, there's a lot of like talk in the ecosystem around this, and I think this was back from around 2018, 2019, when Evan Butcher defined what he saw as a digital platform. And a digital platform is a foundation of self-service APIs, tools, services, knowledge, and support arranged as a compelling product. And I think the compelling part is really the important bit in this quote. And this has since then just like this idea of creating internal products exposed to our development team has just grown and grown and grown. So this is from the team topologies, where they define what a platform team is. And if you look at this definition, it's provide a compelling internal product to accelerate delivery by streamlined teams. So a compelling product again. So we need to build a product and expose that internally to our developers. And now this was from last year's KubeCon in Atlanta. Centasso published this O'Reilly report around platform as a product. And I think that this has been a topic in the ecosystem for the last couple of years, that now we really need to treat our platforms as products. So to have basically, we treat them as evolving products as we would do if this was an external thing. So we do like get feedback, we create experiences around how it is to run on this platform. So the missing abstraction is sort of the full picture here is that you as a platform team on a Kubernetes platform, you absorb complexity by building different products that you expose to your developers. And I think observability should be part of one of these platform products so that you can create a really nice curated experience for your developers so that they just get everything out of the box. So let's take a look at observability and how it sort of looks today, because I think many of the same mistakes are happening in this space as in the early days of Kubernetes. Because observability promised quite a lot of things, that you would be able to do faster root cause analysis, you would be able to understand what is going on in your systems, and with that understanding you would be able to lower MTTR, and that of course also like implies that you're reducing guesswork. But I think the reality is probably more around where do I start? There's so many different tools here, and which tool is the right tool, and how many tools do we need? And why is this metric suddenly spiking from this CNCF project that I just put into my platform? I have no idea what it does, but I get the insights and now it's spiking, so what is going on? And then this thing that I call human correlation, where you have an ID in one tab, in one system, in Prometheus, whatever, then you need to go figure out in your logging system or your tracing system, and you do a lot of correlation across basically browser tabs. And that is what I would call either manual or human correlation. So you become sort of the correlation engine in this. And if you sort of visually try to like display this again, we have a lot of different browser tabs, right? We have our logs in one browser tabs, we have metrics in another, we have traces in a third. We also have maybe something around the real user experience from the mobile application or the website, whatever we have. But we also have maybe profiling when things go wrong and we want to like inspect what is actually going on in the systems. And as everybody in here probably know, that naming is hard, right? So we also, in all of these different tabs or systems, we might also just have different ways of defining what maybe a level is in this case, or what a service name is. Maybe it's app in one, and maybe it's service underscore name in the second, and something else in the third one. So that correlation just is becoming really, really hard, and especially when we have maybe hundreds of thousands microservices. So finding that needle in the haystack when something goes wrong just becomes even harder. So the current reality is that we have a lot of fragmentation in this space. We have, in each of those browser tabs you just saw, there might be a complex query language or filtering mechanism, or however you sort of figure out how to find that data that you're needing. And in many cases, we also have vendor login, because this space has been built around, especially if you buy a product from a vendor from like 5 to 6 years ago, or 5 to 10 years ago, you would have like an agent that is vendor specific. You might have some frameworks you need to add into your code base, or some libraries, and then you are really, really locking yourself into that particular vendor. And yeah, this is the metadata inconsistency, or the naming inconsistency between the different tabs is also a big problem in this fragmentation space. And because of all of this complexity in this space, it often leads to either only instrumenting 1 or 2 of these signals, and that, of course, is not like the way you want to do this. Because each of these signals provide like a view into your system, like a different view into a system. So you're missing out on sort of this lack of unified insights across all of these different ways of looking at your system. But this isn't necessarily a tooling problem. I think there's been great like examples of great tools out there in each of those pillars. But I think the problem right now is that those pillars only represent this partial view of your system. So we need to figure out how we are correlating across all of these, in this case, 3 pillars. But I don't think the 3 pillars of observability is really how we should frame this. Because as you saw in the browser tab example, there was like 5, and there's probably more coming. So let's like stop talking about the 3 pillars of observability and call them signals instead, and recognize that there is more than just the 3 of these. And also, we don't have a metrics problem or tracing problem or logging problem. We have a systems problem. There's something wrong with our system that we need to understand and figure out. So looking back at the early days of Kubernetes, we had all of these tools, and we see the same thing in the observability space. So this is, you're probably familiar with this, the CNCF landscape, but this is only like zoomed into the observability side of things. And just in that category, there are so many different tools to choose from. Luckily, there's one up there that is sort of the foundation for many of these that I'm going to talk a little bit about today, which is OpenTelemetry. So many of these tools either integrate or build on or in some way interact with OpenTelemetry. So that is hopefully the sort of the answer to a lot of the problems, but we'll come back to that. So we have a lot of powerful primitives, but we don't have like this default experience of getting it easy up and running and getting the insights that we need. We need to do a lot of things ourselves. But luckily, as I mentioned, there's this shift happening right now towards OpenTelemetry, and what that shift really provides is a shift towards correlation, so that you are able to actually find related information because you have like a standard for how you're defining and naming things, which also allows you to maybe when some kind of metric is spiking, you are able to correlate that to the actual span or the trace, and then from there on, jump into the actual logs and figure out what is actually going on. So it really allows you to reconstruct the chain of events. And that is really nice when you're woken up 3 a.m. in the morning and something is wrong, instead of you having to find an ID in somewhere and put it into a third system and trying to understand what is going on. So this is really a shift towards OpenTelemetry as that standard, as the foundation for how you're basically observing your systems. How many of you are familiar with OpenTelemetry, just by show of hands? Great. How many are actually running OpenTelemetry? A little bit fewer. Okay, good to see there's some running it. So OpenTelemetry is an open source project designed to basically provide a way to standardize tools and APIs for generating, collecting, and exporting telemetry to wherever you prefer. That's really up to you. So it started as a merger between OpenCensus and OpenTracing 6 years ago, something like that. And it's become the de facto standard for distributed tracing, metrics, logs, and now also profiling, which is in alpha state right now, and also browser instrumentation. So you can basically do all the 5 signals that I was talking about before. And the main goals of this project is really to unify telemetry, be vendor neutral, and be cross-platform. And cross-platform in this sense means that you are able to basically use whatever language or whatever you have out there and use OpenTelemetry for that, because there's SDKs in all different languages. You can just take them down and start instrumenting your applications. And actually last week, OpenTelemetry just graduated. So now it's become a CNCF graduated project, which finally happened. It took a long time. So So that is awesome to see. That also means that hopefully more and more will start adopting this. In a nutshell, what it is that it's a data model. It's API specifications. It comes with this thing called semantic conventions, which is really where we are defining what things are and what values they can take. So this naming problem thing is sort of a solved problem now, because now we all as a community agree on an HTTP code. It's http.response.status.code, which is really nice. It's a good foundation to build on top of. It also has this these different libraries and implementations for all of these different languages that you might have. And it also comes with utilities such as a collector that allows you to collect all the telemetry and send them again to whatever backend you want. And then it also has an operator and other tools, and I'll show you the operator in a second. But it's not proprietary. It's not an all-in-one observability solution. So you still need a data storage. You still need some kind of dashboarding solution. You still need some query language on top of all of this. And it's not feature complete yet. There's a lot of stuff going on in this community. That I think the OpenTelemetry GitHub organization itself has around 100 different projects at the moment. So there is just a lot of stuff that happens in this space. And if we look at sort of the velocity report from the CNCF report that I think was published a couple of months ago, it's still one of the top projects in the ecosystem. Especially, it actually is above Kubernetes on PRs plus issues. So there's just a lot of momentum going on right now. And that's also visible in the survey that came out in January from last year, that actually 49% of the respondents for that survey are saying they're running OpenTelemetry in production. An additional 26 is evaluating. So that's really awesome to see. So the signals, I already mentioned those 5 signals. Whereas metrics, logs, and tracing is stable, and profiles and real user monitoring is more sort of on an experimental alpha state. But the superpower of the project is really this correlation piece, that it really allows you to correlate these different signals so that you can actually jump between them, and they can provide you this partial view into your system and putting it together so that you actually get system understanding out of it. And this is how you would simplify a setup. You need to instrument your application somehow, and there's different ways you can instrument your applications. Either you do this manually, just writing instrumentation, you import the SDK, you start writing and setting everything up. But there's also auto instrumentation that you can, for Java, for example, you'll download a Java agent, you will put that in the Java tool options with the agent flag, and then you can basically run that and it will do all the instrumentation for you. Similar for many other languages. But you can also do this using a Kubernetes operator that I will show you in a second. You can also basically observe all your infrastructure. So for Kubernetes alone, there's 5 different receivers that you can configure in the collector to receive either from the kubelet. You can get all the metrics from there. You can have it pick up Kubernetes events. You can get all the kube API stuff out there. So you can basically instrument everything. And this is not only for Kubernetes. This is for basically all the projects that you're most likely using. You can do that. And then you can put this into the collector. There's a processing pipeline. So you can do a lot of interesting things there. You can redact certain things. If you have sensitive data, you can just redact that. You can do filtering, you can add things, you can basically do whatever you want. It's a kind of a data pipeline. And then you can export this to wherever you feel like you want to export it. Whether you decide to go with a database for each signal, or you find some vendor out there that has a unified backend. So basically what OpenTelemetry is doing is that it's standardizing how telemetry is collected. And hopefully it will be sort of the last observability agent you will ever install, because once you are on the standard, you can just point your exporter to whichever vendor or whichever tool you want. And that is way more easier than ripping out agents and frameworks and stuff like that in your code bases. So I would definitely recommend everyone to start looking at that if you're not. Now, let's switch gears a little bit, because telemetry without context is just data. We really need context around things, right? Because if you're just looking at a graph like this, any guesses what this could be? Just shout them out if you have a guess. What? A heart signal. Yeah, that's a good one. It could also be response codes. It could be approval ratings by, I don't know, some president in the US. I don't know. But actually, this is sort of the number of legs versus how cute they are. So the context, right, really matters. And what do I want to say by this is that we talk about system context in different ways that, in our systems, right? Because we have all the way down to the infrastructure layer, we have which data center is this running in, what region in the cloud, what availability zone. It could also be which cluster is this on sort of the more platform level side of things, which namespace, which deployment was this, was it a cron job, whatever, what was it? It could also be the container layer, sort of on the compute layer, what process. But then we come sort of on top of all this, then we have the architecture, right? The thing also has a name. Who owns that name is sort of the last step. Is all of this matters in terms of the context that this thing is running in and that you're producing your telemetry in. And the cool thing about semantic conventions that I talked about a little bit earlier is that there's really conventions for most of these layers, except the top one, but I'll come back to that. So all of the basically the scores up here is basically links to the semantic conventions where you can see how a cloud is basically being generalized as the cloud.platform equals AWS or whatever it might be. Same for Kubernetes, same for OSs, system processes, whatever. I think there's even like hardware stuff and batteries, and so there's semantic conventions for a lot of different things. But the organization part is kind of missing, which is a little bit of a shame. But I know there's work going on in the ecosystem to define basically service.owner or something like that. But there's also tools that allows you to do that yourself. Like OpenTelemetry Weaver is a project under the OpenTelemetry organization that basically allows you to define your own semantic conventions. So you could also build your own semantic conventions around department or whatever you find relevant for your organization, which is quite nice. So all of this context, of course, needs to be provided out of the platform. And you as a platform engineer sort of have this dual responsibility, and you, of course, need to observe the platform. So you need all of this information when you're like observing your own stuff. But you also need to enable your developers to get this insight, to understand where they're running their applications. And if something goes wrong on a node or whatever, you need to understand and be able to correlate that this is coming from a problem either on my side or on the application side. And how can you then do this? Well, I think we need to talk a little bit about sort of paving the path to observability and providing observability as a platform product. And what I mean by that is really that the development experience from this is that you just deploy your service as a developer and you get everything out of the box. You don't have to deal with instrumentation or like setting up all of these things. You, of course, add your own business context for whatever you are like building in that service, that is your responsibility, but all the other stuff underneath, like the HTTP requests, all of this is basically something that should be provided out of the platform. But then you might be asking, how do I actually do that? And I think operators is really the sort of the delivery mechanism for some of this, and especially from the collection and instrumentation part. So in the OpenTelemetry project, there's this thing called the OpenTelemetry operator, and what it allows you to do is that it allows you to do auto instrumentation basically via custom resources. So there's a custom resource called instrumentation that you can apply in your cluster. You define some configs where data is being sent, where's my collector running. And then you add an annotation to a pod, and whenever that pod is being deployed into Kubernetes, it will auto-instrument that application for you. I will show you, I think I have time to do a demo, so maybe I will just do that in a second. But let me just finish this. So OpenTelemetry is really like how telemetry is produced and collected. You still kind of need to, as a platform engineer, figure out what kind of mix of vendors and open source tools do you want to use for sort of the backend side of this. And some of the things that you should like take into consideration when you're doing this is how should my developers actually interact with this? How should they ask questions about my systems? How, also in this world we're living in today, how do agents understand and interact with the data that I'm producing out of this? Because I think that is definitely sort of the next step in all of this, is that we will have agents that are becoming like a stakeholder of the platform to some extent as well. So you need to think about that when you're choosing your tools. Because you probably know this, that if you put garbage in an LLM, you get garbage out, right? LLMs need structure, they need something to reason about. And that thing is really what OpenTelemetry is also providing from an observability perspective is this specification and the semantic conventions that we now agree on, that this thing is called this, and it means this, and it can take these values. And if your telemetry is conforming to that, you will basically have like rainbows and unicorns and stuff like that, because now the LLM can actually start reasoning about what this thing is and start correlating the different signals and come up with understanding of and providing basically incident resolutions and stuff like that. Come on. So it basically allows you to start asking questions about your system. Of course, this depends on the tool that you're using and displaying your data in. But you can basically ask questions around any issues with my system today, or why is service something failing, and help me to understand this trace. I can see there's 1,500 spans, and I don't want to like go through them all. So like surface the most important things for me. But I think this is just the beginning. So this is like sort of the reactive part that we're in right now. This will become proactive. You'll see agents running and doing this automatically and figure this out themselves. Maybe even do, PRs back into your code base if it has that access and that knowledge. So it's going to be an interesting sort of time for the next, months probably. So without the conventions, the semantic conventions, and the correlation sort of fails. And without the correlation, AI just guesses. But with this structure and with the context that you're providing, AI now starts to reason about the data and about the problems that are going on. So why observability as a platform product? Well, it will reduce the cognitive load that I talked about in the beginning. It will just be that experience for developers. They're just building the features, creating whatever value they are like hired to do, not run infrastructure. And they will get all of this out of the box. They'll get the understanding, they'll get the signals. And then, it will be sort of the foundation for AI-driven workflows as well. So developers can actually focus on delivering business value with observability as a built-in kind of a safety net. So I think I'll skip to the other mic. And hopefully this is on. Perfect. So I want to just quickly show you what I talked about before. So this is a local cluster that I have running on my machine. It has basically a to-do application. So it has a front end. You can see the front end part up here. It has a to-do backend, which is basically just an API, and it talks to a database. And that sends notifications through RabbitMQ to a notification service. Pretty simple to-do applications. There's no reason for basically the async part other than I wanted to try it out to see how it works. And then I have, in the cluster, I have, as you can see, we have some agent collectors. So I'm running the OpenTelemetry collector as two different deployments, one as a daemon set and one as a deployment. The daemon set runs on every machine, so it can pick up logs, it can talk to the kubelet, it gets all the node information. Whereas the central one is more around talking to the Kubernetes API, figuring out how many replicas, deployments, stuff like that, getting the events from the API, which is nice. So that's sort of the application. If we then just quickly show you. So this is the front end. Zoom a little bit. So I can just add a to-do in here, and you can see that it receives the notification. That's perfect, awesome, it works. If we then move into the observability side of things, so this is Jaeger. I'm only showing you this using open source tools. I don't want to be vendor pushy or anything like that, so this is just sort of the tracing part of it. But in most cases, you probably want something that is more across, like a unified solution. But this is just to show you sort of the tracing part of it. So if we do this, we say create to do. 942, I think that must be the one. So you can see now I have all of this is basically just being automated out of the box. So you get a lot of insights. You can see there's what do we have? We have some repositories as an insert into a database. It communicates, it publishes a message to the other service that is then consuming all of it. That's awesome, that's great. But what I want to show you is basically if I start from like a new service. So my platform team in this case are using Backstage to create abstractions and just make it easy for me as a developer. So you probably have something similar to build some kind of abstraction for your developers. And I cheated a little bit because this is the actual service. So this is this is the scaffolder in Backstage. And what you would use in the real life is probably like, this is the best practices for how I run a Node service or Go service or how I configure whatever it might be. I already pre-filled all of this. So this is nice. We'll just create the service. Then my platform team in this case provided me some nice steps that I'll just copy and move into the terminal. So you can see now I created this validation service. So this service is basically a service that the goal is that the to-do service just asks the validation service whether or not that this to-do is allowed or not. And if it is, it says 200 okay, otherwise it gets a 400 for some reason. I can just quickly show you the code. Because the thing is that, and what I really want to show you is that you don't have to manually instrument or do anything in the code. So this is the code. It's a really poorly written Node application. But there's nothing specific in here around metrics or traces or spans or anything like that. It's just the logic. So if we run the command, so this is basically my CI/CD. This is not how you would do it in production. This is only for demo purposes. So it's building the application, and it's going to push it into the cluster, hopefully, in a second, using kind load. Again, you will have probably some CI/CD system. You will have Argo or something running in your clusters to apply all of this. Great. And part is initializing. That's great. While it does that, let me show you what the platform team in this case then also added, because if we take, let me find it, the deployment specification, which was also created through this scaffolding process. So the platform team in this case added this annotation, which tells basically the OpenTelemetry operator that this application wants to be instrumented automatically. And I mean, this is a Node.js one, so I need to inject Node.js instrumentation into this application. That's nice. So that's basically how the operator is instrumenting all of this. So let's go back and just do a request. So I think there was 3 words that was bad. So bad is a word that is not allowed. Oh, I forgot one thing. So I forgot to actually, I have in the to-do service, the team owning that service is basically, they have a feature flag that I need to enable for it to actually call. So let me just quickly do that. And we can see if it's actually working. It's running, that's perfect. Let's try again. And now it fails. So now it's part of this, basically this like request chain. And if we go and look at the actual telemetry now, we should hopefully see that all of this is now part of basically the traces that you saw before. And this, you can see now actually the validation service is here. So it's already part of the distributed trace that we have from before. And in this case, it fails. We can create, let me just create one that goes through as well. So by hotel swag or something. Oh, sorry. Let's find the trace. And there we go. So it's all automatically instrumented. It's part of the trace. You can see that the to-do service now calls the validation service, and that is also instrumented with some things. It has information about, all kinds of different information that conforms to the semantics, cluster ID, blah, blah, blah. All of this is part, all the context is now here and can be used for basically anything, which is pretty nice. So that is one way you can basically build this into your platform and make it easy for your developers to get this out of the box. So from the development perspective in this case, they didn't have to do anything. They just had to write the logic, apply it into the cluster, and they get the defaults out of the box. So I definitely encourage you to start building some of this into your platform now, because as you probably know, AI is moving pretty fast these days, right? And if you don't have this foundation, basically this knowledge and this agreement and contract about your telemetry, utilizing all the AI to get the insights into your data, into your systems, is kind of hard, because garbage in, garbage out, right? And you will probably fall behind. You will see your competitors are just automatically resolving all of this, and you're spending more and more time on actually understanding what is going on. So that was all I had for you. If you are interested in getting started with OpenTelemetry, feel free to scan this QR code. It's to the OpenTelemetry for Dummies book. It's a good way to get started. It just has the basics. It takes like an hour and a half to read. Also, just a quick shout out to Merge Forward, which is a part of the CNCF. It's for basically trying to create communities for everyone. So if you're interested, just check out the QR code there. It's a great course. I'm an ambassador for them as well, so check it out. And with that, thank you so much for having me and for listening to this talk.
Okay. Thank you, Kasper, for the talk. It was great. We have nothing at Slido, so maybe they will leave that for the panel discussion in the evening.